So this next demonstration focuses on the mill turn environment and the ease of use, how quickly and easily it is to produce a toolpath on this very complex part using Edgecam operations. We simply digitize an icon and Edgecam on the screen will prompt us for information. Clearly and concisely information is gathered by the system, and now we see a very user-friendly dialog box which now represents how this part is going to be machined. We can clearly see the tool, in this case a 45-degree cap toe holder is being used. The feeds and speeds are automated in Edgecam, and using this easy to use dialog area, the user has quickly and easily began to produce his first toolpath. Onto the finish turning command. Again, we digitize our feature which is born off our solid component. We use the finish turn operation. As we glide through each of the commands, Edgecam guides us and prompts us, informs us how to do this command. Already we've got two major cam instructions completed. Obviously we always check our components inside Machine Simulator, which is standard inside Edgecam software. And in this particular case we not only see that the toolpaths are gouge free, but we also want to make sure that the particular holder and cutter and indeed the turret and all other machine tool members are safe and collision free. We're now going to move on to the centre bore area where we need to produce a rough turning cycle, something like a G71 can cycle. In our case we can simply split the components in half, give the user an easy and a simple way to look through the part. Now we're going to update the stock, so the user is always machining the latest model of material, thus guaranteeing no fresh air cutting. We now begin our rough turning command, and again Edgecam guides us through a simple dialog area. This picture speaks 1,000 words and helps the user to understand how he's going to produce his toolpath. Return on investment is realised because there's no difficult help files to read through. It's all on the screen. At a touch of a button we have now produced our rough turning cycle, and you'll notice how the use current stock command was used in this particular case. Now what we want to do is check that our toolpaths are not only collision free, but we also want to make sure that we can see the position of the component for our next piece of machining, which is 5-axis simultaneous machining. This is performed all inside one environment. Again, the user is prompted on the screen for what information is required by Edgecam, and then what we'll simply do is begin to answer back on the dialog area. Clean, simple, straightforward interface. As we can see now, Edgecam will now produce, Edgecam will now prompt us for the tool, and as we move through our dialog area, we're seeing that the toolpath has straight away been produced. We can simulate here on the screen. It gives us an extremely good clear indication as to whether this is gouge free, but we not only want to check the toolpath, we also want to check that the machine tool is also collision free. We need to make sure that we're not going to be scrapping off a piece of extremely expensive material and causing downtime. Inside the Machine Simulator we can stop the machine process at stages. We fast forward, bypassing the stages that we're not interested in, the areas that we've seen already, and focusing in the areas that are important to us, in this case the boring cycle, making sure that again the back of the tool is not colliding with the bore. We zoom back, and now we're going to check in our next stage, are there any collisions? So again we are informed by the system when and where there is a collision taking place. In this case, red is danger. We look for a red gouge mark on the component, and it's better obviously to have a gouge here in the Machine Simulator than on an extremely expensive piece of material which would cause potential damage to the machine tool. We now go back into Edgecam where we simply correct the lead in lead out movement on that 5-axis simultaneous swarf operation. And now that we know that that command is safe, we can drag drop using the standard Windows technique and copy, using the drag drop feature, a second cam instruction where we can now ask Edgecam to move the identical cam instruction over to the next area. and again we get an identical swarf machining command. This practice of copying CAM instructions allows the user to very quickly and very easily guarantee that he is safe machining. This is standard practice throughout Edgecam, where we can use PCI templates and Strategy Manager and other such techniques to speed up the production of CAM instructions, and obviously allow our users to produce CNC code right first time, every time. Here we see our demonstration is finishing off inside Edgecam Machine Simulator, where we have two perfect 5-axis swarf commands as well as a number of turning commands. The whole process has taken less than 5 minutes. Thank you.